Friends, now I am going to show how to solve a truss problem using ANSYS workbench. So basically we are going to carry out a finite element analysis to solve a mechanical problem. So what we'll be doing is, first we'll open the ANSYS workbench, and static structural can be opened by double clicking basically in this option. And once this is set, since the question which we are going to solve says that the material is structural steel, so we'll not do anything to the engineering material because engineering material takes structural steel by default. And then we will open the geometry. Basically geometry I have opened and made for you. So what we have to do is, first we have to select this xy plane and then go to the sketching mode. And once we go to the sketching mode, we have to just take a line and draw from this to this, and then this line, and then from here to here. Then once we draw the lines, we can give the dimensions like, first one we can give vertical selecting this point to this point, then horizontal selecting this point to this point, and this point to this point. So I have already done this. Then once you give this dimension, just then we have to connect these 2 points with one more line, and these 2 points with one more line. Then what we have to do is, we have to select this option which is there inside concept. Select what is that, make bodies from sketches ना, कुछ तो था, lines from sketches, या ये जो है ना, ये option lines from sketches. So ये वाले option already, because I have selected, so I'll remove it. इसको कैसे remove करना है, delete है ना, remove. तो this one we can remove. And then one more thing which we have to take in cross section is to specify the cross section. Circular वाला select कर लेना है. फिर ये पूछेगा कि what is the radius. So in this question the diameter is told as 0.75, तो radius उसका half 0.375. So with these two things, the design modeler part is over. Then we can open the this ANSYS model है ना. In there the material is already specified structural steel. We need not do anything with that. Now cross section is already specified. All these things will already be there. So इसमें क्या है, mesh का size we need to specify. Mesh का size we can specify as per our convenience. Like 50 set किया है, we can give 10 also, because it's a lined body, it will be running very fast. So I'll just give a generate mesh command. So mesh has been generated. So mesh has been generated, and as we can see, but this is not that close enough, so we will make it still more finer. We'll make it 5 and generate the mesh again, so it will give us a little finer mesh. So now what we will be doing is, we have specified for this vertex can be selected from this vertex. We have specified the boundary condition that it will be fixed in all direction except in y direction. Y is free, because as we can see in this question now, there are some rollers, so this point is free to move in the vertical direction, so y is free for this point. Then the other one is for the top vertex. Here everything is fixed. Okay, it is actually free to rotate, but since we are specifying displacement, so displacement is 0 for all the three directions, x, y, z. Then we have to specify the force, which is the same for both the nodes or vertices, whatever you call it. So it will be 10,000. Here it is 10 kips. 1 kip is equal to 1,000 pound of force. So 10 kips will be 10,000. So minus signifies that y positive is towards up, so minus means negative towards down, it will be there. So it is, we have specified for both the cases. And now I'll just give a run. If I give a run, it will take less than 4-5 seconds actually to run it. Yeah, it is running is over. So now in the results there are many things which we can see. One is the question asks about nodal displacement and the stresses developed in the member. So what I'll be saying is that once you insert, okay, you have to go here and insert. There are so many probe tools, and insert stresses also we can insert. But beam result, here it will tell us about the axial force. So this axial force has come from there, because the force on each member can be obtained from here. And the deformation can nodal displacement can be obtained from here. So what is the use of this one thing? This can serve as a check actually. uh, yeah, if you see that I have this result tab will have a probe option. So if I'm probing the forces, if you see, it is same throughout the thing. So it is expected. And this probe for this member, this is the like force. For another member, this is the force. This is compressive, this is tensile, again this is still more compressive. So this is the way we calculate the different forces in different members. Okay, so that's all for this video. I'll keep it short. Thank you. Okay, before ending, I just wanted to show that in this case the total displacement at the tip of this truss member is 7, almost 7. So thank you once again. I stop.